S-Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, in order to describe the motion of simple pendulum, how the pendulum motion works, so we will study over here what is a simple harmonic oscillator, and its two types like mechanical and electrical harmonic oscillators.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. Myself Narinder Kaur. Now today we will start with this simple harmonic oscillator. So simple harmonic oscillator is basically when the body oscillates about its mean position. So that such type of motion is known as simple harmonic oscillation. And all type of oscillations, they will take place in the straight line. For example, if this is a simple pendulum, okay. Now if this is a simple pendulum motion, and we will give force to this. Now this pendulum that will start oscillating about its mean position. So this type of motion that will occur in a straight line. So such kind of motion that is known as simple harmonic oscillations. Now we want to describe what kind of oscillations are there. So that will be described mechanically or electrically. So now when the body oscillates about its location or the mean position along the straight line under the influence of force, means in the starting we have to apply the force. So starting the force is applied to the body. After the application of force, the body will start oscillating about its mean position. So that's why now due to its motion there will occur the displacement. So why displacement? Because it depends upon the direction. So that's why the body will start displacing from its mean position, or you can say that from its equilibrium position. So such kind of motion is known as simple harmonic motion. So that means when the force that is pointed towards the mean location and is proportional to displacement, because as soon as the force is applied on the body, it will start moving. So as the body moves, that means there is some displacement. Now when the large force is applied, it will move to the large distance. When the small force is applied, it will move to the smaller distance. So that's why here the displacement of the body that will be directly proportional to force applied. Now that means the force applied to the mean location, and that will be proportional to the displacement of the body at that point. So that will be proportional to displacement. So such kind of motion of the body that is known as simple harmonic motion. So this type of motion is known as simple harmonic motion. That means body starts swimming. So it will swing from one position to the another position. So such now this kind of motion, that is a periodic motion. So why this is called periodic motion? Because now it will start oscillating from its mean position to the final position. Then it will come back to its mean position. So that means these oscillations, they will be repeated over here. So that's why this is called periodic motion over here. Now, so this kind of motion is known as mechanical harmonic oscillation. So these type of oscillations are the mechanical oscillation. Now we want to describe it electrically. Now for the electrical harmonic oscillation, we will go to the motion of atoms inside the crystals. We know that all the crystals, they are made up of atoms. Now when they are at 0 Kelvin, means there is no heat, all the atoms, they will be stationary. They are not moving or they are not vibrating about its mean position. As soon as the temperature of the crystal that is rise up. Now when the temperature is increased, so when the temperature is increased, now the atoms, they will gain some energy. So here the gain in temperature or the increase in the rise in temperature, that is equivalent to force which is applied mechanically. So the difference between the mechanical harmonic oscillator and electrical is that in mechanical harmonic oscillator, the force is applied. So here the push or pull, so such kind of forces are applied, that is a mechanical force. While in electrical motion, the temperature is rises. So the energy or the force is given in terms of temperature. Now when the temperature is applied over here, the atoms in the crystal, they will start displacing towards its normal position. So they will start moving from its, due to thermal energy in the atoms, they will start oscillating from mean position to the vibrating machine. So such kind of simple harmonic oscillator is called the electrical harmonic oscillator. Now we know that when the atom or the crystal, in the crystal or when the bodies, they will move from one position to the another position. So there will be a restoring force acting. Now this restoring force, now here the displacement is along this direction, and the force, it will push it back to the mean position. So this kind of force is known as a restoring force. Now they will be in the opposite to each other. So the restoring force will tries to bring the atom or to bring the body to its normal position or to its mean position. So the restoring force, we know that everyone loves the equilibrium over here. So the nature loves equilibrium. So that's why now when the body move from its mean position or from its normal position, there occur restoring force in the backward direction. So this restoring force will tries to bring the body back to its normal position. So now, so under the influence of such restoring forces, or for the individual atoms, when they vibrate, they will come back to its normal position. So that's why there comes starting the oscillations of the atoms. Means in the crystals, if there are large number of atoms, now when we apply heat to these atoms, when they are heated up, so due to that they will start vibrating. So all these atoms, they will start vibrating. So that means they will come displaced from its mean position. After some time, they will come back. So there will be acting of a restoring force. Now this restoring force is acting in the opposite direction to the displacement. So this force is given by minus kx over here. So such kind of motion are known as, or the oscillations are known as simple harmonic oscillations. Now that means in the simple harmonic oscillation, so classically we know that the restoring force that will act in the opposite direction. Means when classically it is written that, according to classically, when the body start oscillating, so it will continue to its position until someone stops it. That means when there is a simple harmonic or the pendulum motion, it will move from its mean position to extreme, then extreme to mean position. So this motion will continue, it will not stop, but that is not so. We know that after some time, when there is a motion of the pendulum, it will stop. So that is explained according to quantum mechanics, because there are some frictional forces. Due to that forces, it will stop over here. Now we know that the restoring force that will act in the opposite direction. So this force over here, we know that the force applied over here, that is directly proportional to displacement. More force is applied means more will be the displacement of the pendulum. Smaller force is applied means smaller will be the displacement of pendulum. Now the force relation, now when this proportionality symbol is removed over here, there comes K. Now what is K over here? K is called the spring constant over here. That means why there is a negative sign? Because they act in the opposite direction. So restoring force is acting in the opposite direction to the applied force. So that means force that is equals to minus kx over here. What is k here? K is known as a spring constant and x is the displacement over here. So that means now this is also known as a Hooke's law. So according to Hooke's law, the force which is acting on the body, it always act in the opposite direction to its displacement. So that means the force or acceleration, you can say that they are directly proportional to the negative sign of the displacement. So now that means they are acting in the opposite direction over here. So due to that, or restoring force which acts in the opposite direction, so that is explained according to quantum mechanically. So the body will stop after some time. So that's motion that will not continue. Classically, it happens when there is no force acting in the backward direction. So that means, so that body will continue oscillating about its mean positions, but that is not so. We know that after some time, its displacement that will be small, because the force is acting in the opposite direction, and due to force acting in the opposite direction, this displacement from the mean position, Now if this is the x1 and that is the x2, after some time this x1 that is always greater than x2, that means the displacement continuously decreases over here. So due to this decrease in the displacement, after some time the body will comes to rest. So that means the force, then the restoring force, that also becomes 0, because when the displacement is 0 over here, that restoring force that will also vanishes over here. So that means when the body is oscillating, so according to classical physics, when the body is oscillating about its mean position, it will never comes to rest. But quantum mechanically, when the body is oscillating about its mean position due to restoring force which is acting in the opposite direction, that after some time the displacement will decreases out and the body that will comes to rest over here. So this is the Hooke's law, which is applied to the real springs for the small displacement, and now that is happened only for the small displacement, that is in the real life examples. When someone swings on the, when there is on the swing, when someone is sitting on the swing, we know that after some time it will comes to the rest. So that is over here now. So this is the, what is K over here, that is known as a spring constant. Now what is a spring constant? It directly proportional to stiffness of the spring. So that means when some body is attached to the spring over here, now if this spring is fixed over this and some body with mass m is attached to this spring over here, now when the force is applied to this body, so after some time when we push this body towards the x direction, now if this is a body with mass m, again this is mass m, now if this is distance is L, now L1, now that is a L2. We know that here the L2 is more than L1. That means the body is displaced toward the x-axis over here and the force is applied in this direction. Now we know that here the displacement occur in this direction. Now when the force is applied over here, restoring force in the spring that will act in the opposite direction. That means if the displacement is along this direction, along the positive x-axis, then the restoring force that will act along the negative x-axis. Now if this is a displacement and that is the direction of force over here, so they both are acting opposite to each other, means applied force is same to the displacement, the direction of applied force is same to the direction displacement over here, but the direction of restoring force is opposite to the, because restoring force always tries to bring this body with mass m to its original position. If the displacement is along this direction, then the force will acting in the, restoring force will act in the opposite direction. So here the negative sign shows the fact that the force F, that is a restoring force, it will act in the opposite direction to the displacement over here. So that means it is in the opposite direction. So it will always try, the oscillations, they will always tries to bring the body back to its equilibrium position. So this is known as, now in order to move this body in the forward direction, some extra forces are also applied. Such type of motions are also known as damped oscillations. Means if we want this body to continuously start oscillating, so some extra force that will be applied, otherwise it will comes to down. That means the oscillations, they will be damped. So such kind of oscillators are also called damped oscillators. So now this is the first part. So till now we have studied what is a mechanical or electrical simple harmonic oscillator. In the next part we will derive the mathematical expression, how the simple harmonic oscillations are calculated, and also we will calculate their solution also.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S Chand Academy. Now in the first part we have studied what is a mechanical and electrical simple harmonic oscillator. Now we will calculate its mathematical expression and how its extrapolation of the simple harmonic oscillator that is directly related to the displacement. Okay, now we have been calculated over here. So for the simple harmonic oscillator, we know that this force that is given by minus k into x. That means this restoring force that is directly proportional to minus, that is proportional to x, which is a displacement, and also which is given by minus of k. So what is k over here? K is a spring constant and the negative sign indicates they are acting in the opposite direction. Means in the starting when the body is in the equilibrium position, so that means in the equilibrium position the displacement of the body or the spring that is 0. Means in the starting, if this is a mass m and the force F, when there is no force, in the starting F is 0, so automatically the displacement that will be 0. So means in the starting when there is no force, there will be no displacement. After that, when the force is applied on the body, then the restoring force will act in the opposite direction. Now force applied on the body that is given by, which is, we know that force is given by mass into acceleration. So now acceleration that can be represented as, that is a d square x by dt square. Now we know that that is given by this much relation. Now that is equals to minus of k into x. So d square x by dt square that can be written as minus k by m into x. Now this is a second order differential equation. So the second order differential equation is here the d square x by dt square plus k by m into x that is equals to 0. So now this is a second order differential equation. Now the second order differential equation that can be calculated and the solution of this second order differential equation that can be calculated as, we know that for the second order differential equation, so this is a, so second order differential equation is d square x by dt square plus k by m. Now substitute this is equals to omega square. So that means this omega square that is equals to k by m. What is k here? K that is a spring constant and what is m? That is a mass of the body over here. So d square x by dt square that can be written as plus omega square x by 0. Now that is the second order differential equation. Now solution of the second order differential equation that is equals to a cos omega t plus phi. That means displacement of the body that can be given by a cos omega t plus phi. Now what is omega t over here? So the solution of the second order differential equation that is given by a cos omega t plus phi. What is a? That is the amplitude. So a that is the amplitude of waves or the oscillations. Oscillations which are associated with moving body. That means the oscillations which are associated with the spring constant or the springs which is moving in the forward direction or application of force, A is called its amplitude. And omega t plus phi. What is omega t plus phi? That is a phase of oscillation. We know that oscillations are the waves over here. Now we know that for the oscillations, these are the waves and the wave they are having the, now there is an amplitude and as well as phase which is associated with the waves over here. So due to that, A is known as the amplitude of the oscillations and omega t plus phi that is known as phase of the oscillations. And what is omega over here? Omega is called the angular frequency. So what is omega? That is the angular frequency of the wave. So that is the angular frequency of the wave. So that means now when the body start moving, that means on the application of force, body start moving in the forward direction. So there comes simple harmonic oscillation. So these oscillations are same as that of wave. So similarly to the wave, there is amplitude associated with the body. With that amplitude is known as A, and omega t plus phi that is known as phase of the wave. So similar to the waves, these oscillations have amplitude as well as phase, and where the angular frequency of these waves, that is given by omega by m. What is omega here? Omega is angular frequency, k is a spring constant, and m is a mass over here. Okay. Now next is the motion. Now we know that here this motion is known as periodic motion. So periodic motion means it repeats itself. That means now when there is a spring over here and this is a body with mass m and the force is applied over here, then there occur displacement on the direction of the applied force, and restoring force acts in the opposite direction. So that means this body will start oscillating about its mean position and original position. So there occur back and forth motion. So such kind of motions are known as periodic motion. So that means there occur back and forth motion over here. So due to such kind of motion over here, so this motion is called as periodic motion. Now in order to calculate the periodicity of this motion, so the time period is calculated. What is meaning of time period over here? That means these oscillations, so these are repeated over here. That means this body that will continuously starting over here. That means now when the force is applied in this direction, the displacement is in this direction and the restoring force will act in the opposite direction. Now due to restoring force, the body will move in this direction. So automatically when it starts moving in this direction, the displacement is in this direction, again the restoring force that will act in the opposite direction. So that will act along this direction, that means along the positive x-axis. So there is a simple funda which included that when the body moves in the positive x-axis, restoring force will act in the negative x-axis, and when the body comes back to the negative x-axis, the force, restoring force, that will start moving in the positive x-axis. So restoring force that is always in the opposite direction to the applied force, or you can say that to the displacement of the body. So due to this there occur periodic motion of the body. Now the time period of these oscillations, so what is the meaning of time period over here? So here t is a time period. Now the time period of these oscillations, that is defined as the number of oscillations which is covered by the body in 1 second. So time period, it is defined as the number of oscillations of the body in 1 second. That means in 1 second the total number of oscillations which are covered by body. Now if this is a time for the 1 second, here is a time period, and along this direction if we are plotting the displacement of the body, now for 1 second, if this is a time period over here, these are the number of oscillation and this time is a 1 second, so this total is known as a time period over here. So this is a time period, or you can say that the time which is taken by the body in order to complete the one cycle, that is known as time period. Now time period that is given by, so here t is defined as, that is a t 2 pi by omega, and now we know that omega, with the value of omega is under root k by m. So this is omega over here. Now substitute value of omega over here, so that will comes m by k. So this is the time period of oscillations. So that can be calculated over here. Now when the body starts oscillating, so there will be the energy associated with the body. So that energy is given by potential energy, which is defined as the energy of the oscillator. So this is the energy of the simple harmonic oscillator, and that is given by the expression which is equals to half of kx square. So that means this energy is proportional to x square. So there is a parabolic variation of the energy over here. So now what is u, that is the potential energy which is associated with the body when it is attached to the spring over here. Now what is x? X is a displacement. So that means when we see its variations along the body, so its variation that will be, now u, that is given by half of kx square. So this is the potential energy. If this is a displacement, and along this direction, if there is a variation of the potential energy, then this variation that is given by like this. So that means now these are the simple energy or eigenstates of the simple harmonic pendulum over here. So the potential energy that is given by half of kx square. Now that means when the x is positive or negative along both the ends, so along both the ends this energy that will be positive over here. So this is known as a potential well, or this is known as the energy associated with the simple harmonic oscillator. So this energy that is equals to, now this is also known as a restoring energy. That means when the body restore to its mean position or to its original position, the energy is restored inside the body. So this energy is known as, also this potential energy is known as the restoring energy in the body. That means it is also known as restoring energy, or you can say that the potential energy. Now this restoring energy is also directly correlated to the restoring force. That means more the force is applied on the body, more will be the displacement, and more will be the restoring force in the opposite direction, and higher will be the restoring energy, or you can say that potential energy which is associated with the body. So such kind of oscillations or motion of the body, that is known as simple harmonic oscillation. So now this is the end of topic, which is a simple harmonic oscillator. So till now we have studied what is simple harmonic oscillation, the difference between the mechanical and the electrical oscillator, and how its displacement is related to the acceleration, and we have also calculated its potential energy associated with the body. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.